All right, this is AP Calculus. We are doing worksheet 7-4. This is going to be the key. Today's date is Thursday, January 9th, 2019. I'm using the TI 83 Plus, even though I have the other calculator, because it's still kind of having some glitches. Yeah, so the main thing to take away from the lesson is that the position change is given by this. So I'm always going to do start plus change in position to get my final position. All right, so we have a particle moving. Here's our window between 0 and 5. Here's our function. Is this the exact same question? Oh my gosh, it is the exact same question. Okay, well, let's do it again anyway. So luckily, I already have this in here. It's the natural log of t squared minus 3t plus 3. My window is between 0 and 5, and I'm going to hit zoom 0 to zoom to size or zoom to fit, whatever that function is called, and it will eventually graph that function. So I need to figure out the start value, well, done. The end time, not value, start time and end time, that's given by our window right here, that's done. And then I need to find all the possible times, or all the times where I cross the t-axis. So I cross here, it looks like 1, it looks like 2, but how do I determine that it is indeed 1? I have to find the value of the 0. So second trace to calculate the value of the 0. So second trace 2, and I'm going to guess 1, so anything left of 1, 0, anything right of 1, 1.5. And then I'm going to guess 1, and it is 1. So I come back over here. Okay, one of the things I have to check is t is equal to 1. And then I have to check this value right here. I think it's 2. So I'm going to do second trace to calculate the 0, 2. Second trace 2, left bound 1.5, right bound 4. I'm going to guess 2, and it is indeed 2. So we have all the possible values of t. I'm looking for the one the particles farthest to the left. Well, farthest to the left, that's kind of like a minimum question. And farthest to the right, that's a maximum question. And then knowing the definition of what f minimum is, that's where I have f prime go from a negative to a positive. So I can already eliminate one of these values. From a negative to a positive, that means I'm looking at this value that goes from a negative height to a positive height. This one goes from a positive height to a negative height. That is a potential max. This is a potential minimum. I'm looking for a minimum. I can ignore this one if I wanted to. I'm going to do the full work to show you guys what would happen though. But you could save yourself some work by eliminating that one right now. Okay, so our start position for all of these is 8, 8, and 8. We're always going to be adding the integral from 0, because we start at time 0. Sometimes this is 1, by the way, so be careful. You always start at whatever that time is to whatever this time is, in this case 1. Always of velocity with respect to t. And this is going to be the integral, again, starting at 0 to 2 in this case. So velocity right there, dt. And then this is going to be the integral, again, from 0 to this value of 5 vt dt. Then I have to do just some number crunching on my calculator to find what those end positions are, and I kind of just circle that time. That's going to be the answer. So coming back here, how do I calculate this integral between 0 and 1, and why am I skipping 0 and 0? I'm skipping 0 and 0 because it's done for us, and this evaluates to just 0. If I have the same number to the same number, that's nothing. You can just cancel it out. 0 and 1, though, I do need to do. So second trace, and I'm going to calculate the integral here. So 7. So second trace 7. The lower limit is 0. So I'm going to type 0 for the lower limit. The upper limit is this upper limit of 1. Hit enter, and it's going to shade in between 0 and 1. We get that as 0.555 rounding. So this is going to be, I can say that this is 0.555 for my notes, and 8 plus 0.555 is 8.555. Let's do another one. Integral between 0 and 2. So a little bit faster. Second trace 7, 0, enter, 2, enter. And it's shading this region. Again, these regions don't go away. And 0.369 rounding. So 0.369. And if I add that, I get 8.369. Just checking to make sure this makes sense. I have a negative area, so I should be subtracting. It should be a little bit less than this one. I am a little bit less, so that does make sense. And I have a giant positive area, so this one should be bigger than 8.369. Even probably bigger than 8.555, since these two areas sum to like a very tiny positive area. This is a giant positive area. So second trace 7, 0, enter, 5, enter, and now it's highlighting all this stuff. I'm getting ready to do my yellow here. It's highlighting, and I get 4.739 rounding, so it should be 4.740. 4.740, adding those together, 4 plus 8 is 12, so 12.740. Farthest to the left, that's the minimum value. The minimum value is here. So when is the question? So the time is equal to 0. So if I actually answer this question, farthest left at t is equal to 0 and position is 8. So that's me answering the question. All right, moving on to a new question now. That's not from the notes from before. All right, we have our function. We're looking farthest to the right, so we're really looking for an f max in this case. So a maximum, the definition of that is going from a positive to a negative. So let's plug everything into our calculator. Our y equals, let's clear out of that. And again, this is going to be sine of x squared. And my window is going to be between 0, enter, and 3. It's kind of hidden here. Between 0 and 3, so 3, enter. And I'm going to zoom 0. So it's going to zoom to that size. We'll get our graph. I'm going to copy and paste this graph in here as well so we can see what that looks like. So copy this graph, paste it in here. Where's a good spot? I'm going to do it over here in the bottom left so that people know what they're looking for. All right, so I need to find these zeros though. So obviously I have my start value 0, my end value 3, so I don't forget. But I also need to find those zeros. So I'm going to go second trace 2, and that looks to be about 1.7. So I'm going to hit 1, enter, 2, enter, 1.5, enter, and it's 1.772. 1.772. I need to find this 0 as well. Well, do I? Okay, well, let's just find them to practice. So it looks to be about 2 point something. How do I know that? This tick mark means 1, this tick mark means 2, so a little bit bigger than 2. I'm gonna guess 2.45. Let's see how close I can get. So second trace 2. So I'm gonna guess between 2 and 3. Yeah, 2 and 3. I'm gonna guess 2.5. Sure, it's 2.506 or 2.507 if I'm rounding. 2.507. All right, my start position is always going to start at 5, start at 5, start at 5. I'm going to add the integral between 0 and 0. That's nothing. That's why we got 5 already. Between 0 and this value, 1.772, velocity of t dt. And I need to do plus the integral between 0 and this t value, 2.507 of velocity of t dt, and plus the integral from 0 to 5 of velocity of t dt. So you might be asking yourself, well, before we had exact values, do I need to store that value somewhere? And the answer is no, because we've rounded to 3 decimal places. If I rounded to 1 decimal place, that would cause some errors. This one won't cause any errors that I've known of, so you don't have to store it. But if you did want to store it, how would I store 2.507? Well, this is now the answer, because we just found the answer is 2.507. So if I get out of this by second mode to quit out of this, you'll notice that if I hit second answer, it is 2.507. So we now need to say, hey, that answer, store that as a variable. You have all of these green letters up here are variables, so I can hit alpha. I'm going to just store it as x. So 2.506. So if I hit 1 enter, right now my answer has been overwritten. So if I hit second answer, if I hit second answer, there we go, my answer is 1. How do I get back to 2.506? Alpha x, and I hit enter, alpha x now stores the value 2.507. So that is how you store the value. And then if I came back up here, let's just calculate this integral, since I forgot to store 1.772. I don't need to though. If I wanted to do a second calculate 7 between 0 and 2.507, instead of typing in 2.507, no, I could actually instead clear that and hit alpha x, and that's exactly 2.507. It looks weird, right? X is equal to x. But you could do that, and it would be exactly, right? Oh my gosh, that's not working. Why is that not working? I guess that doesn't work. Maybe you have to store it as a different variable. Let me try that. Let me get out of this. If I have alpha x, that does store here. What happened? That got overwritten somehow. I don't know how. Okay, let me play with some things. So if I come back up here, second trace 7 0. So no, I don't want to do that. I want to find the 0 again. So let's get out of this. I want to do second trace 2 between 0 and 2. I'm going to guess 1 to get 1.772. Okay, that's now stored. Let's get out of that. Let's store that answer that we just got to something else. All right, yes, I know that's happening. I know that's happening. All right. So I'm going to store that as a different variable. I think the variable name got messed up. So I'm going to store it as a. So now if I do second trace 7, my lower limit 0, my alpha a, this should now work. Okay, it does work. So you can't use the value of x, I guess. I chose literally the worst value to choose. And I can get an exact value. So this is equal to, and I'll put this as 0.895. So this is 0.895. 0.895 plus 5 is 5.895. And notice the difference here. What if I instead did second trace 7, 0, 2, and I don't use a, I actually type in 1.772. What would my answer be in that case without using a stored variable? My answer will still be 0.895. So it doesn't affect anything. Well, at least to 3 decimal places, right? Let's go ahead and do this one. So second trace 7, I'm going to go between 0, enter, and 2.507, enter. And it's now shading this region. You can't see it. That's this loading bar is still doing things. 0.430 rounding. So 0.430. And if I add those together, I get 5.430. 5.430. All right. Between 0 and 5, so I'm going to do second trace 7, 0, enter, 5, enter. What did I do to? Upper limit is, oh, I can't go to 5. It goes to 3. Oh, that's a mistake. So sorry about that. 0 to 3. What if it gave it that mistake because it was out here, out of the graph? It only works within the graph window that I have. So 3 will work. Let me come back here and change this number to a 3. That's my bad. I got confused with the start condition. And I get 0.774 rounding. 0.774, and adding that to 5 gives 5.774. So the minimum value that it's not asking for is 5, but the maximum value when it's farthest to the right is the biggest number, which happens to be right here. So let's circle that. It happens right here at this time. So it is asking when. So it's really asking for 1.772, but I'm going to include the information 5.895 just in case it was asking where is the farthest to the right. So the answer is, and I have room down here. Oh, I could just type this. It's a little bit faster, right? So let's change the color to red down here. So we can say that the particle, oh my gosh, is farthest to the right at t is equal to 1.772 and at position 5.895. Perfect. All right. Moving on to, that was question 2. I guess I should be labeling these as well. This was question 2. This was question number 1. We are now on to question number 3. Object is traveling in a straight line, has initial position. So this is going to be the start. I should be labeling these. Start. Did I label these other ones? I mean, it already had the start for us, but we should be labeling this as the start as well. We should be labeling this as the start as well. You always need to find the start. So I found it. There it is. It's at 2. And it's at the time. This is the start position, and this is the start time. The start time is 0 in this case. And we have velocity. What is the position? So this one, I don't even need to make a table. It's not asking for a max or minimum. It's just saying, where is it? So this one is just going to be, it's still the same thing. It's like start plus change is equal to the end. But instead of making a table, I literally know what's happening. My start position is 2. My change is going to be from my start time to that end time at t is equal to 3 of my velocity. So that's the cube root of this 1 plus t squared dt. And then I'll get my answer. So let's do that on our calculator. So there's actually 2 ways to do this problem. The slow way is doing it with a graph. Let me show you the slow way, and then I'll show you the faster way. So the slow way, either way, you still have to enter in the equation, so you might as well do that right with me now. So I have to do the cube root. Mr. Sindel, there's no cube root on here. Well, there's 2 ways to do a cube root. There's math, and then there's a cube root right here, or you can do the cube root by doing this one as well. So I'm going to do 4 because it's easier. Let's show you how to do a 4th root while I'm at it. So if I want to do the 4th root, I would have to hit... I'd have to clear out of this. I'd have to do 4 first, and then I do math 5. Now this is now saying the 4th root of 5. Let's clear out of that. Let's actually do the cube root though. So that's math 4. So that's a cube root of 1 plus x squared. 1 plus x squared. And there is our function. Cool. So let's get out of that. So the slow way again is graphing. So I go to Window. I am between 0 and 3, so I already have that. 0 enters, 3 enter. Then I go zoom 0, and this is why it's slow, because it has to graph it. Not only does it have to graph it, then on top of that, it has to calculate the integral. So it is going to be a little bit slower. By the way, as a note, if you need to cancel this, if it's taking too long, hit on. On will cancel the graphing or cancel the integral. That's like clear won't do anything. Okay, now I need to calculate the integral between 0 and 3, so I say, okay, I'm going to do second trace 7 between 0, enter, 3, enter, and it's going to say, okay, it's going to slowly shade in this region. You can see why this method takes so long. That's why I want to show you the shortcut method. And done. Okay, so 4.512. This is 4.512, and we get our answer using the slow method of, I'll do it in red, 6.512, and we can box that. Okay, how do you do it the faster way, the shortcut way? You still need to enter the y equals, so we did that. And then from there you can go to this screen without graphing it. You can do math 9, the integral, and it looks different on your screen. The integral between 0 and 3, so integral between 0, or sorry, on the TI-83 plus you have to do vars, let's get out of that, vars right, enter 1. The first function with respect to x from 0 to 3. Just find this integral. Type in this integral using math 9. And look, 4.512. We got that so much faster than waiting for it to graph, then hitting second trace, and blah, blah, blah. So this is the method I'm going to do from here on out. Hopefully you'll learn that method. All right, we are on to question number 4. And I should check my time so I'm not interrupted here. We get out at 11:18, so I'm out of time. I only have 30 more seconds. I will continue this video at another time. All right, I'm back. So, yeah, let's plug in our velocity equation. So I'm going to go y equals, let's get rid of that guy. Don't need it anymore. This is going to be cosine of 2 minus x quantity squared. And looks good. All right, so I'm going to get out of this. I'm going to do math 9, and then okay, I'm just making sure I got my initial condition from the last question. So it's the integral of vars right, enter 1, with respect to x from 0 to 3. Does that look? Position is 3 at time 0, so I'm going to add 3. Oh, what is the position of the particle when its velocity is first equal to 0? Darn it. We need a graph for this one. Okay, so window, we don't know. So it's bigger than 0, but I don't know. So I'm just going to randomly choose a number. I don't know, 10? Sure, and then I'm going to do zoom 0. Let's see what's happening here. What is the position of the particle when the velocity is first equal to 0? Okay, well, right there. So I'm going to zoom in between 0 and 1. I did way too big. So window, 0, enter, 1, enter, and then let's do zoom 0 again. Zoom into that spot. So I need to find this time. Once I find this time, then I can do an integral between 0 and this time that I find, and that will be the answer, and I have to add 3 to the position because it's a start value. So if I come back over here for the notes, I'm always going to do, what time am I looking for? And that's what I'm searching for right now. I'm going to do start plus change, and then I will get my answer, the end, the position when it's at that time. So to find this time, we're finding this intersection that's going to be second trace. I'm going to find the 0, so 2 between 0 and 1, and I'm going to guess 0.5, and it's probably 0.6, I'm guessing. 0.655. So t is equal to 0.655. My start is 3, so I'm going to say that's my start up here. Always label it 3, and then I'm going to do plus the integral from 0, because time starts at 0, to 0.655 of that velocity. I'm just going to say vt instead of writing cosine of 2 minus t squared dt. So second trace to calculate the integral from 0 to 0.655. I guess we could have hit second answer. Will that work? I'm scared. Let's try it. Let's clear that and do second answer. Hey, it does. Okay, I didn't know that. Learned something new. And boom, there it is. Negative 0.184. Negative 0.1. Oh, I should be writing it over here. This is negative 0.184. And then if I add that to 3, so if I get out of this, I do 3 plus the answer. I guess I could just do plus, because it does answer plus, and then 3. And I get to 2.816, which makes sense. 2.816, and that is the final time. And I'll say at t is equal to 0.655. I always like including both the time and the position because I'll never make a mistake that way. We are on to number 5. We have acceleration, interesting, not velocity. If the velocity is 2, so it's still a start. It's not a start of position, it's a start of velocity. And then we're looking for velocity. So it's kind of the same thing, it's just up another level. Instead of velocity, it's acceleration. Instead of position, it's velocity. So everything is still the same. Oh, by the way, time starts at 1 now. So start time is 1, start position is 2, or start velocity is 2. And we're going to go from t is equal to 1 to t is equal to 2. So we know our integral. I'm kind of skipping ahead here. What t are we looking at? What is our start? What is our change? And then we'll get the end velocity in this case, end velocity. And then just kind of making I don't need to make a full table, I'm just kind of showing you the similarity here. So we're looking at time 2. That's the thing we're trying to find, so 2. What is our start? Our start is 2. Position 2, and we're going to add this to the integral from where to where? Well, I start at t equals 1, so not 0 anymore, 1, and I end at this time here, 2, and it's not velocity, it's acceleration, dt. Alright, so let's do all of that. I first need to plug that value into this function into the calculator, so y is equal to, get rid of u, this is going to be natural log of 1 plus 2 to the power of x, and there it is. I'm going to get out of this. Do I need to graph this? No, I can just type this in verbatim. I can even add 2 from the very beginning. I don't want to do that. I want to figure out what this value is in case you made a mistake. So math 9, I'm finding integral between 1, enter. Oop, I was thinking of graphing. Let's go to, and so it doesn't quit out of it. Vars right, enter 1, so of the y1 function with respect to x from 1 to 2. I know it's a little bit different on the newer calculators, but there it is. And that value is 1.346. So this is 1, do it in yellow, 1.346, and then I add that to 2, and I get 3.346. 3.346. And that's at time is equal to, I mean, it's in the question. I'm not going to rewrite it this time. There it is. And second to last question, number 6. We have velocity and the position. Given that yt is the position, that is representing, this is position. So this is saying at time is equal to 0, the position is 3. So this is all the start information. I'll write start. And we need to find when time is equal to 2. So this is at t is equal to 2. So if I'm making my table, we still need a t, and this is going to be 2 in this case. We're going to do start. The start position in this case is 3 plus change, so start plus change, and that change is going to be the integral. The integral starts at time is equal to 0 in this case, and we're going to go to this value of 2, and that's going to be our velocity, dt, and that will equal to our end value that we're going to try to find. So there is our table. And I literally just enter all the stuff in. My VT. Oh, by the way, there is an even quicker shortcut, I suppose. You don't have to enter things into the y1 function. For example, if I don't have anything there, check this out. I'm going to do, let's get rid of that, math 9. Normally we type y1 in here, or you type it in the newer calculator over on the side. You can actually type in x sine of x squared all in there. This now is the function with respect to x from 0 to 2. And you'll get the same thing as if you had a y1 in there. So, I mean, this is a little bit of a shortcut, not that much. Let me write this down. 0.827 rounding. So this is 0.827, and then I need to add that to 3, so I get, I'll just do this in red, 3.827. That is y2. And no units. All right, we are on to the final question. This is question number 7. A particle is moving along the x-axis. Here's its velocity. We know that the start position, the start is 1, and it starts at time is equal to 0. So what just happened there? Go away. When you undo things on this computer, sometimes it doesn't like it. There it goes. Okay, so we still need a time. We still need to find the start position. We need to find the change, and that will give us the end. All right, so there is our table. Farthest to the right. Okay, whenever you're looking for farthest to the right, now we're looking at a bunch of table values. So that's probably why we have so much room here. We need to have quite a few things. We have to have the start and the end for the times. We have to have 0, we have to have 3. And then we have to have anything where it touches the x-axis, where it crosses through the x-axis. So these are like the f relative extrema. So where are those relative extrema? Well, we have to graph it first. So let's go ahead and program this into our calculator. So we have our y equals, this is going to be a negative symbol down here, not above the plus sign again. And then it's going to be x plus 1 in the parentheses, and that's going to be times sine of x to the power of 2, so x squared divided by 2 inside the parentheses. And looks good. Yeah, okay, so our window is between 0 and 3, so 0 and 3. And then I'm going to zoom 0. All right, so we're looking again, where do you cross the x-axis? Those are going to be the values I'm going to put over here. You could put all of them, but notice, in this question, we're looking for farthest to the right. We're looking for a maximum. So if I come back over here, this is the maximum, or an f maximum. What is the definition of f max? That's where it goes from a positive, or f prime, I should say. F prime goes from a positive to a negative. So this is a graph of f prime. It's a graph of velocity, right? So where does this velocity go from a positive to a negative? Nowhere. This is a potential minimum, not a potential maximum. So I don't even need to include it on the table. There's no other place where it crosses from a positive to a negative, which means if I want to skip a step, I could ignore that point. But just for the sake of, what if it was asking for a minimum? How do I find that? More practice, more practice. I'd do second trace to do calculate. I'd calculate the 0, left boundary 0 to 3, and just any number in between is fine too. And it will tell me 2.507. So 2.507. But I need to clarify, you do not need to do this. That is not going to be an answer, and we'll see that in the end value. But let's go ahead and fill this in. So the start position is 1, so 1, 1, 1. We're going to add the integral between 0 and 0 and blah. I don't care. That's going to be nothing. This one I do care about. Between 0 and 2.507. This one I care about because it's other than 0, 0 to 3. And then these are all of velocity. So I'm just going to write v of t dt, v of t dt. So 1 plus 0 is 1. I'm a very good mathematician, right? Okay, now this one is a little bit harder. This is going to be, and again, I don't need to use this graph. You could. I'm going to speed it up a little bit. Let's get rid of that old problem. Speeding up, I'm going to say, what is the math 9, the integral of my vars right, enter 1, my y1 with respect to x from 0 to 2.507. That is equal to a negative amount, which is why we didn't even include it in the first place. Negative 3.265. negative 3.265. And when I do that plus 1, because again, the adding your start condition, your answer is negative 2.265. Come in here in blue, negative 2.265. That's clearly not the maximum in terms of the values over here, right? And finally, between 0 and 3, which is probably, I mean, according to our graph, I don't know. I think this area is bigger than this area, so I'm pretty sure just by looking at the areas of this graph, 1 is going to be bigger, because then you have a giant negative area and then a tiny little positive area. And I should really be screenshotting these for the notes so people know if they're getting the right answer without looking at the video. Hopefully, guys, you're getting a graph that looks like this. All right, I'll put that, sure, right there. So now I'm going to do, let's get out of this again. I'm going to do math 9 to find the integral of, R is right, enter 1, or enter if you want, y1 with respect to x from 0 to 3 this time, 0 to 3. Hit enter, it's doing its thing. Negative, it's still a negative number. It's almost the exact same, oh, it's a little bit smaller, right? That change was negative 3. This is negative 2.197. So negative 2.197, and if I add that to 1, I get negative 1.197, obviously. I don't know why I did it on the calculator. I'm being silly. Negative 1.197. Which of these is biggest? Well, the one that's positive, right? So this is the answer. So where is it farthest to the right? At time is equal to 0. And I'll type that in a sec, but the bell just rang. I have to get ready for my pre-calc class. All right, yeah, sounds good. All right, and then, yeah, let me just type out the final answer, or I guess I can write it. It's asking for, find the time t. So the answer is at t is equal to 0 is the answer. And notice that the position is 1. All right, and that is the final answer. And that concludes worksheet 7-4 solution.